Okay, now look at this question. It says mother's age is 2 more than square of her daughter. When daughter grows to her mother's present age, mother would be 1 year less than 10 times the present age of the daughter. Find the present ages of mother and daughter. Okay, I can clearly see there are three conditions given in this problem, and they have asked you two things. First, mother's present age, mother's present age, let it be x, and the daughter's present age. So daughter's present age, let it be equal to y. Now according to first condition, mother's age is 2 more than square of her daughter. So x should be equal to 2 more than y square. Okay, so this is the first condition. So let us say it is equation A. Now the second condition is very important. It is hidden in this statement, underlined, you know, in red color. When daughter grows to her mother's present age, which means there has to be some difference between mother's present age and daughter's present age. Let us say that difference is equal to d. This is a very important equation. So I am writing the difference between the ages of mother and daughter is d. If that is the case, then this condition can be used in the next condition, which is the mother would be 1 year less than 10 times the present age of the daughter. After mother after daughter reaches the mother's age, so after d years, mother's age will be x plus d. So mother's age would be x plus d after d years, and at that time the mother would be 1 year less. She would be 1 year less, so minus 1. She would be 1 year less than 10 times the present age of daughter. 10 times the present age of daughter is y, so it should be 10 times y minus 1. This is a very important equation. Okay, first we need to understand when daughter grows to her mother's present age means after a certain amount of time. And what is that certain amount of time? It is x minus y, and that is equal to d. So after d years, mother's age, which is x plus d, would be equal to 10 times daughter's age, which is daughter's present age, which is 10 times y minus 1. So x plus d is equal to 10y minus 1. Now I can solve these equations because there are three equations and three unknowns. So let's solve these equations one by one. First, substitute the value of d from equation B to equation C, and you will get 2x minus y is equal to 10y minus 1. Now substitute the value of x from equation A in this equation D. So you will get 4 plus 2y square minus y plus 10y minus 1. So this is a quadratic equation. I'll write it on the other side over here. So this will give me how much? 2y square my plus 9y, right? Plus no, not 9y. It will give me 2y square minus 11y, right? It's not 9, it's minus 11y plus 5 is equal to 0. So this will, now let's find out the roots of this equation. This will be minus 10y minus y plus 5 is equal to 0. This will give me 2y common, y minus 5 minus 1 common, y minus 5 is equal to 0. So I'll get 2y minus 1 times y minus 5 is equal to 0, which means y should be equal to half or y should be equal to 5. If y is equal to half, then x will be equal to, let's put this value of y in equation A. You will get 1 by 4 plus 2. It's what? It's 2.25. 2.25. Mother's age cannot be 2.25, so this is impossible. So let's not even try and go over there. This will not give us the answer. So the second condition is true, which is y is equal to 5. If y is equal to 5, you will get x is equal to 2 plus 25, which is 27. Yes, these are the appropriate present ages of mother and daughter. So x should be 27, y should be equal to 5. So the mother's present age will be equal to 27 and the daughter's present age will be equal to 5.